Everyone wants to write a really good research paper. I think we all have dreams of somehow coming up with attention is all you need. But a prerequisite for that is to at least understand how a standard research paper is structured and to understand how it works. So for the purpose of this talk, we'll think about the minimum viable research paper. This is the space of papers that really are just okay. Now, this isn't to say that there aren't great papers that fit inside this realm. And it also doesn't apply to the kind of average paper you'll see on the archive. A lot of random papers are pretty bad. We're interested in at least having the paper be highly structured, even if it's not great. To make the distinction a little bit more clear, I'm going to be talking about structure, coherence, and clarity of your writing. In distinction from this, papers that are great also include a fair share of creativity, clever use of rhetoric, and very, very detailed empirical precision and execution. Honestly, I really don't know how to teach those things. I've seen people do it in practice, but it comes from a lot of hard work and really getting the okay parts down before moving on to the great aspects. To make the talk more tangible, we're going to use a running example throughout the entire talk. The paper we'll use is from ICLR 2023, and it's entitled GPTQ. Now, the details of this paper aren't necessarily important for the rest of the talk, but you've probably seen it before. It's one of the first papers that showed that you can quantize large language models to a much lower bit rate with a simple algorithm. This technique was used for distributing a lot of models, such as Llama, so they could be run on local GPUs. This paper is great. It's really creative. It's widely applied. It's been cited almost 500 times. But for our sake, that really won't matter. What I like about this paper is that the structure of the paper is really nice, and it represents a great example of what we'll call an okay paper. So before diving into the details, I want to give you a high-level sense of how you learn to become a better writer. Specifically, you want to read these papers not as a student trying to learn from, say, some experts, but as a fellow author. That means you want to work backwards and really try to read the paper as if you were writing it. That means analyzing and understanding the individual choices that an author made in the process of presenting their work. When reading in this style, you should be extremely generous. Try to understand the specific choices they made and why they made sense to the author writing it. But in addition, you should also read with a critical eye. You are in some sense the target of this work, so if there are parts you do not understand or feel confused, that's additional information that you should use for thinking about what went wrong in the writing. I don't just mean this in a theoretical sense, but it's actually a very good exercise to go and sit down and actually try to piece out the individual choices that were made for a given paper. So one thing I like to do for papers that my group writes is to start with a high-level pictorial outline of how the paper will be written. We can apply the same technique to other people's papers to have a sense of how they allocated the limited space in the paper to the different sections. Here we can see an example of the paper we'll describe today. This diagram illustrates the relationships between the different sections, their proportional spacing, as well as choices of where to put different graphics, graphs, algorithms, and tables within the paper itself. If you can do this exercise for a couple papers that you like, it'll be more helpful for you understanding how to lay out the structure of your own work. Starting from this high-level structure, this talk will go through each of the different sections and try to give you some actionable advice that you can use when writing each one of these sections. Specifically, I'll break down each section into having a one-line goal, a series of tips for writing, and an example from the paper we are studying. I'll break the paper down basically into two parts. The blue sections represent the explanatory portion of the paper, and the red sections represent the empirical part of the paper. Now I will note, I'm assuming a basically standard ML empirical paper as the paper of interest. Some of these tips will be useful for data or analysis style papers, but obviously you'll have to adapt these recommendations to the format. Okay, let's get started. So when talking about the goals of each section, I'm going to borrow this famous illustration that describes one view of how research is done. The circle here represents roughly the frontier of human knowledge. The red line represents the contributions that are made in a given paper. The red line includes lots of hard work, but only at the very end does that hard work actually pass through the frontier of knowledge to produce some new information that people reading a paper would benefit from. One of the challenges when first writing a paper is to learn to focus on these two aspects, which we'll call the novelty and importance of the work. The novelty here will represent roughly the angle in which you are pursuing new knowledge, whereas the importance will represent how far you pushed past what was known for that given problem. In the introduction of a paper, your goal is to convey these two facts to the reader at a somewhat high level, so they can appreciate what was new about the work and also why it was worth pursuing in the first place. In some sense, this part feels trivial, but I want to state that what's critical about the introduction is to really not say anything else, and to narrow down what you're claiming to as minimal an area that you can defend in the paper itself. With that goal in mind, let's think about some tips for writing the introduction. One tip I give to early students is to explicitly outline a set of 3 clearly defendable contributions. This can be pretty broad depending on the style or the structure of the paper, but it should be a list of 3 things you feel like are novel and important and also justified by the results that you ran in the experiments for the paper itself. When doing this, you want to think about the audience that this is targeted for. Things like importance can both be the scientific merit, but also things like the practical usage of this approach. If you can make it possible to, say, run a large language model on someone's laptop, that's as much a contribution as proving a new theorem. The other thing to note is that while the introduction comes first, it's often worth writing the rest of the paper beforehand, and then really thinking back what contributions you made, how they were structured, and why you think they're important, and putting those in the introduction. Let's now turn to our example paper, GPTQ. The introduction of this paper is relatively straightforward and directly follows a basic structure. The first paragraph is going to argue for the importance of this method. It shows that LLMs are widely used, but notes that they utilize too much memory at inference. In the next paragraph, it will discuss the novelty of this paper, which is that compression is a well-studied topic, but many of the standard compression methods do not apply to large-scale language model inference. Given the first 2 paragraphs, the paper demonstrates its contributions, which will be an efficient post-training quantization method, the first successful results, which show 4-bit language model quantization, and early results showing more extreme quantization of these models. Reading the intro, even if you're not versed in this field, you can get a sense of both the importance, the novelty, and the specific contributions this paper will claim to make. Starting from here, a standard machine learning paper will move to the explanatory sections of the paper, the related work, background, and method sections. Some papers will take a somewhat different format, but this is standard enough that I think we can use it as our base form. The goal of these sections at a high level will be to make clear the contributions of the paper and set things up for the later empirical sections. Generally from the introduction, people move into the related work section. The goal of this section is to demonstrate how the contributions in this paper differ from others, and it's particularly focusing on the novelty of the paper itself. We can think about this in our graphic as thinking about the angle between our contributions and other contributions in the past. One common confusion is that people think about this almost like a bookkeeping section, that they have some responsibility of just listing out a bunch of other papers. If you're doing that, I think you're somehow missing the point. You want to utilize these other works as a way of explaining your own work. Think about the audience here as someone who's very well versed in this topic and really is trying to give you a generous reading to understand what your paper is about and how it differs. One process I like for putting together this section is to start by first making a spreadsheet that describes 3 facets of your work, and then collecting a list of papers that belong in each of these facets. Note that these should not be papers that your paper uses. Instead, you want other attempts at reaching a similar goal as your work that maybe took a different approach or veered off into a different direction. Again, I'll note that this section really shouldn't be bookkeeping. You don't want to waste 3/4 of a page just listing a bunch of papers. The goal here is to use these other papers as a way of contrasting with your own work, to demonstrate how these approaches are different, or to later set up the baseline section for your paper itself. A good related work section will be highly explanatory. In our example paper, the related work section is 4 paragraphs long. First, there's an introduction paper, which describes the main contribution as being post-training quantization of LLMs. The next 2 paragraphs describe the 2 facets of related work. These 2 facets follow directly from paragraph 1. Facet 1 is post-training quantization, and facet 2 is LLM quantization. None of these papers do the full problem, but they both target 2 different facets of the goal of the paper. Paragraph 4 then describes how this work will contrast with both of these approaches. Specifically, it argues why the contributions of this work will go beyond either of these 2 previous lines of related work. Zooming into the text for paragraph 2, we can draw some more specific writing lessons. First, if you look at the blue highlight, you can see how you would translate from a spreadsheet into the related work itself. This paper is quite concise. It just goes through a bunch of different methods, describing roughly how they work and how they relate to the main goals of the paper. If you look at the orange highlight, you can see how the paper contrasts its results from the results of related work, specifically highlighting the fact that these approaches work with low parameter models, whereas we're going to be working with much larger models. From related work, it's typical to go into a background section. Generally, the rule of thumb I give students for writing background is to think about it as an import statement. Roughly, you're going to say from NeurIPS import X, where that's the additional information you're going to need in order to describe the novelty and contributions of this paper. Now, this has 2 different components to it. First is you're allowed to import anything you want, but you shouldn't import too much. You don't want to have random things that don't come up later in the paper. A kind of classic example of this is that a lot of papers that use transformers describe attention in detail in their background section. But if the paper and its contribution is really about an application of this model or something about the feed-forward layers, you've done all that work to import this information that you're basically not going to use. In the paper we're studying on GPTQ, they actually don't describe transformers at all, even though all their experiments are on transformers. That's because the key method they're going to describe is really applying to any very large parameter model and doesn't utilize any specifics of transformers itself. So remember, the goal is to set up the foundations so that you can explain the contributions of this paper. That means you should think very carefully about how you set up your notation to make it explicitly clear how later contributions will be described. But while doing this, you really want to make sure you have sufficient technical background, but also minimal technical background. You don't want to introduce notation that will make things more confusing, or to bring in technical material that won't be used or even useful to the paper itself. All these things add extra cognitive burden for the reader. The last thing I'll note is that this is not a linear process. As you write your method section, you'll find that you'll need additional technical background, and you'll have to go back and add additional statements to the background section. This again is similar to, say, writing code and having to add additional import statements as you go. I really like the background section for our example paper. There's no introduction, it jumps right into technical material. It describes 2 different techniques. The first is general neural network quantization, and it does this by setting up a general optimization problem. What's nice about this first section is it's going to apply both to our method and also to the baseline methods. This is general material that we can use multiple times throughout the rest of the paper. In the second part of the background section, they give kind of a mini tutorial about a specific form of quantization that's used in this paper. This tutorial is particularly nice because it connects to some early work in neural networks that utilizes a very similar optimization approach. This paper is both kind of teaching kind of core material and also setting up its ability to utilize that material in the next section. Staying high level, let's look at the first paragraph of the background section. This is a simple 1-paragraph description of the optimization problem that underlies quantization of neural networks. After a short first sentence, this paragraph immediately goes into the technical details behind this optimization problem. Starting with the word concretely, it defines the optimization problem itself and the variables that will be utilized for finding quantized versions of the model. A couple sentences in, we already have equation 1, which will be the goal throughout the rest of the paper. The green sentence introduces additional constraints, which again apply generally across both the baseline approaches as well as the main method for the paper itself. Before going on, I want to take a quick tangent to talk about a tip that my advisor gave me when we first started writing papers together. The tip was to think about there being 3 different levels of writing, and for every sentence in your paper as belonging to one of these levels. The first is high-level writing. This is descriptions about why we are doing this or what the parts of a given system are. The second is summarization style writing, where we're going to talk about why something might work or talk about what it does. The third is technical writing, where we're going to describe the declarative process for goals or talk about the specific details about how a process works or how it runs. This third level of writing should be nearly compilable. It should type check, it should have the right shapes and sizes, and someone reading it should be able to understand exactly what's going on. The advice he gave is that when writing machine learning papers, you should never be on this second level. You never want your writing to fall somewhere between a high-level description and a technical process. You should know precisely whether each sentence is high-level or technical, and you should use clear transitions to indicate when you are moving between the different levels. If you go back and read that background section, it's extremely clear when they're moving between levels 1 and 3. Generally, the background and method section should be mostly at level 3. Different groups write their method section in rather different ways. When we put together the method section, the goal is to say, if I had to explain this to myself 6 months ago, how would I explain it? I put it that way because the goal of this section is not to explain every detail about how you arrived at your results. It's to convey what got you over the hump, kind of past that frontier, in a way that someone technical could get it, but maybe not the full path of discovery that led you to that point. Another way of putting it is that you want to help someone else up that hill. A classic problem with the method section is that it just grows out of control. You've been working on this problem for a relatively long time, and so there's a lot to say. Generally, there are 2 constraints that keep the section manageable. The first is that you really should try to introduce nearly no new notation in the method section. If you need something, you should go back and put it in the background. Another tip is to start by sketching your approach top down. Think about the contribution in terms of modular components that you can describe independently. If you do it this way, you avoid the common mistake of describing the method in terms of the order of discovery. Finally, you want to plan ahead a bit when writing the method section. Almost anything you write here is going to have to be tested in the results or analysis section. Don't spend a lot of time talking about things that you're not going to test later on in the paper. Stepping back to our example paper, we can see that they modularize their approach into 3 different steps. When they write the paper, they first describe what these steps are, and then in each of the different steps, they start with a high-level intro, that's at level 1, and then immediately move into a level 3 low-level description of that step. They interleave diagrams that describe specific aspects of the problem with technical descriptions with full-on mathematical explanations. After describing these 3 steps or modules, they then produce a full algorithm written in documented pseudocode. This brings together each of the different approaches into something that can be tangibly implemented by a technical reader. It's a bit hard to talk about the actual methodology of this paper, but we can look a bit at the discourse structure of the writing. Here they've introduced a problem with previous approaches, and they start their section, again at a high level, by talking about how this observation allows them to resolve the core problem. They then switch to a low-level description where they say, concretely, we apply the algorithm, etc., in order to resolve the approach itself. Throughout this section, they're using a lot of technical notation, but it's all been introduced in the background section. If you were able to follow their mini tutorial about how different quantization approaches work, each of these different symbols was described and would be fully understandable to the reader. That all being said, this section is relatively concise. They're basically just providing the details that someone would need to figure this out, and just enough technical detail to make that possible. They're not really hand-holding the reader through this material. After methods, we move right into the empirical sections of the paper. Different papers will allocate more or fewer pages to the empirical versus explanatory sections. I've seen anything from 20/80 to 80/20, depending on the contributions of the work. That being said, if you are going to have an empirical section, the purpose of this section is to check the contributions of the paper. By the time you get to the empirical section, the reader should have in their head an expectation of the experiments that they are going to want to see. You should not be introducing new experiments or really new ideas in these empirical sections. The standard paradigm of these papers is really just to set up the dominoes and then try to knock them down. So speaking of dominoes, the next required section is some sort of experimental setup section. This is by far the most straightforward section of your paper. Honestly, there are not many choices here. My main rec for this section is not to overthink it. Just write everything down that was required to do your experiments. At first draft, this will be 2 or 3 pages long. You can have the most junior person on your team do it, and they'll do quite a great job. You then take about half of this and move it to the appendix, and keep around things like metrics, data, and baselines. Everything here should really be just the facts, no speculation. Keep things concise, keep it detail-oriented. My rule of thumb is that I want readers coming out of the experimental setup section already with a good idea of exactly what the experiments in the results will look like. If you find yourself adding a lot of details in the results section, you should go back and move those to the experimental setup section. Different writers have different philosophies about this, and if you're trying to write a great paper, there are lots of things you can do, but it's a pretty good way to write an okay paper just to keep it in the experimental setup section. Our example paper follows this to a T. There are several different subsections, each describing one part of the structure of the experiments. Here we're looking at the baseline section. This section both lays out explicitly what baselines will be used. At this point in the paper, we have a pretty good sense of what these are and how they relate to the method that we are considering. This paper also does a nice job of talking about the baselines that are not included, specifically citing papers and describing in the experimental setup section why these will not be in the experiments that we will see later on. Modern deep learning papers are incredibly experimentally intense, and often many of the important details will not fit in the experimental setup section. It's not uncommon to see papers with dozens of pages of appendices describing everything that's going on in the experiments. Certainly there's no harm in including these if this is the style of your paper, but also don't feel like it's necessary. If your experiments can be described concisely and completely, that's also a great sign. Experimental setup should lead right into the results for the paper. For some papers, it might be clear what the experimental results are for. It's to show how much better your approach is than all the previous ones. But I think increasingly, some of my favorite papers in machine learning really are not about simply improving upon the previous baselines. The goal of the results section is really to verify the conclusions that you stated earlier in the paper. This may be about one of many different things. It could be about speed, it could be about accuracy, but it could also be about interpretability or scaling properties, or one of many different properties that people are writing about these days. You should think about these results tables as being the evidence that supports the earlier explanatory parts of the paper. That being said, when writing the results section, the main thing you should have in your head is that the tables and graphs are the star here. You really want to represent each experiment that you're doing with one table. My recommendation is to first make these tables and then include one paragraph of text describing each one of these experiments. In the text itself, I don't want new notation, I don't want new methods, I don't want new datasets. Everything is set up so that the reader knows what these experiments will be, and the text should really just be a summary of the conclusions of these tables. In some sense, the reader has the tables, so it feels unnecessary to write this text. However, the text is extremely useful as a way for the reader to verify that they're on the same page with you as to the conclusions of those tables. That's not to say they will immediately agree with your conclusions, but it does help them at least understand what claims you are making so that they can evaluate them. Here's the representative results paragraph from our example paper. This paragraph considers experiments for language generation. These experiments are shown in Figure 1 as well as tables 3 and 4. This paragraph references these experiments, which have already been described in the experimental setup section. The main body of the paragraph simply describes the key takeaways from the table. Specifically here, it describes how the method from the paper outperforms a baseline that was previously introduced. It references the precise values in terms of differences in perplexity from these two models. Again, this information is fully available in the tables. Seeing it here simply reinforces the contributions that the authors of the paper claim to make. We could probably do an entire other video about how to construct experiments for a research paper. For now, let's focus in on how you present tables that you've already constructed for a paper. Specifically, the main rule of thumb is that each table should show the results of a single experiment. You want some hypothesis and some result to be very clear from the structure of the table. When presenting these tables, the captions should be declarative. Don't use a word like I or we, but simply state the experiment and provide enough information such that the table is interesting to a reader seeing it in a standalone context. Finally, when constructing the actual table itself, you should sort the columns in such a way that it's very clear what the main comparison is. Separate sections so that like compares to like, and highlight things in a way that makes it clear to the reader what was being tested. Here's an example table from the paper. We can see what experiment is being conducted here immediately from the caption. In addition, enough details are provided such that we can resolve any uncertainty we may have about things like batch size and length. The actual table itself makes it clear both what is being tested and also the different experimental conditions. We can also very clearly see in the speedup column what the final top-line number is for these different experiments. This is a rather concise table, but it conveys a lot of information about the underlying method. I will intervene here, though, and say that this table is pretty ugly. I think a major improvement to this paper would be to switch to a prettier table representation. I'll include some links to some descriptions about how to make nicer tables in LaTeX in the comments. I encourage all my followers to immediately reject any paper with a table they consider ugly. Okay, so the final content section is the analysis section. There are lots of different ways you may utilize analysis. I like to think about it as a way of checking the robustness of the contribution. That is, if we zoom in just on the part of the paper that represents its novelty and importance, analysis is really checking whether local changes to that method would have changed the main conclusions of the paper. That's not to say this section is minor in importance. For serious people studying your research paper, analysis is going to be the most useful and the one that provides the most insight about the research we should be doing going forward. Unlike some other sections, there is a lot of creativity in the analysis section. As the author, you get to come up with the most important questions that were not asked in the results section. These are often specific questions along some facet that go beyond simple questions of accuracy or speed. As someone with an NLP background, I really like the analysis to include qualitative analysis, specific examples where the method failed or succeeded beyond expectations. In machine learning papers, it's more common to see ablations, where you consider how specific choices in the method section would have led to better or worse results. Another thing that's common to see is an exploration of what the limits of the method are. Could we go even further than the results in the paper, and where would things start to break down? Another fun example is thinking about some of the adversarial properties of the model. Would small changes to the data or the settings of the system itself lead to very drastic decreases in performance? One thing I'll note, though, is that you should really avoid somewhat random experiments or aspects of model or dataset trivia. It's really not true that the more the better in these papers. Everything you describe or write down should really add insight to the reader of the paper that moves them beyond what they've seen so far. If you find yourself adding some experiments that you don't personally find interesting, it's better just to cut them and have a somewhat shorter paper. The example paper looks at several of these different analysis components. In this example, they're considering a task that goes beyond the basic language generation task they considered in the results. This task is meant to somewhat push the limits of how this approach might be used, both with a slightly different task and also at a very high level of quantization. Here they find that the approach seems to continue to do well even with further limits of quantization, although it does lose some accuracy. This information is particularly useful for people who actually went and applied this to all sorts of other tasks after the paper was published. Okay, so we've seen how in these 7 different sections you construct the foundations of your paper. Here we can go back and look at the high-level structure of this paper, seeing how all these sections relate, where graphs and figures are utilized, and the relative proportional size of each of the different sections. I encourage you to make this graph for your own paper. This should give you a sense of what you're communicating to your reader and how you're balancing the different contributions of your paper. Specifically, the main lesson to take away from these graphs is how each of the sections interact with each other and can't really be written independently in a coherent manner. Even when putting together a paper with multiple authors, it's important to agree on this high-level structure and what the terminology and standardization will be throughout the work. Of course, even an okay paper needs a pep talk. And one thing I've noticed over the years is that writing a paper tends to be an area of high anxiety for new students. Here are a couple tips that I can give you just to think about how to go through this process and how to get to the end of it. The first is one piece of advice I really like, which is to write drunk, edit sober. This is not to say you, really should get wasted before writing your paper, but I think drinking a beer or a cider and just going through your first draft is not a horrible idea. Specifically, you want to make sure that you keep on writing and not kind of go back and reread everything you've written with every new sentence. Just getting through that first draft and getting something you can edit is really key to the process. Another thing that goes without saying is that writing needs to be a kind of flow state if you're going to make any sort of progress at all. What this means is that when you're writing, the phone needs to be in another room or down the street. I really recommend going to a library or a coffee shop or somewhere different just to make sure you can get through your first draft. When doing this, you just want to make sure you feel comfortable, feel professional, and kind of have a glass of mint tea as you go. Actually, in retrospect, reading this slide, it seems like all my advice for writing is beverage-based. Maybe that's a good sign I've been recording too long and need to go have a glass of wine. So with that said, good luck, and I'm extremely excited to read your paper. Send me a draft. Thanks.